Oh, you know what? I got it. Welcome, Genevieve. Welcome, Eugene. Welcome, Eric. Welcome, Kimberly. And welcome all of you who are watching this. This is actually the very last webinar for y'all, unless you want a redundant webinar tomorrow. But this is the week 11 webinar because next week is finals. And we don't do a webinar for finals because some of you will be done because you can take it Sunday. And then the course is over. So this is it. And let me talk about a plan today. So let's share the desktop. So we have the first normal thing that we do is Q&A. And then we're going to do chapter 13, which is ANOVA. And I'll talk about that in a bit. And we'll do an example of ANOVA, talk about the ANOVA requirements. Just let you know, from the original book that I grabbed all this out of, we're not doing all of the original chapter 13. So I got rid of a few sections. So it's a very short chapter for us because we're only doing a piece of it. And that way we have a chance to get ready for the final, because that is really important in terms of, in terms of your grade. That's a biggie. So, but I will talk about at least somewhat today, ANOVA and the requirements to do ANOVA. And then I'll talk about the final exam. So you do have a final exam that can be taken on Sunday, a week from tomorrow, or a week from Wednesday. Those are the three choices. And there's times, and I've sent those out in announcements. So hopefully all of you can make one of those times, because what I did is the second exam seemed to work for just about everyone. So I kept those times because that seemed to work. And then the third exam worked for just about everyone too. So I'm just using it. So that's an early morning, early afternoon, and an evening. So it's kind of one of everything is what I'm trying to do for times. And that way I know we have some people across the world, and that way there'll be a time you don't have to be, awake at your 3 in the morning. So hopefully that'll work for everyone, but it needs to, because it is the final, and that's an important thing. So we will talk about that, and I'll spend some time today on that, but at the end. But I will answer any questions you have that aren't about the final exam right now, because final exam questions are for later. Any questions about anything that is not the final exam? I know we haven't done anything in a while because we just had Thanksgiving. And hopefully you had a relaxing and safe Thanksgiving. COVID got way bad recently, so everything seems to be closing up. So hopefully none of you have any big issues with it.
Professor, it's Melinda. I have a question.
Sure.
So on my grade, right now I'm above an 80, so it says I'm passing, but when I was below and I was like a 78, it said I was failing. Does that mean I'm wrong?
Yeah, so all I could tell you is I'm sorry. I can't figure it out. I have no idea how to change those settings. So ignore that word.
Okay, because I was a little panicky, like I'm above an 80 now, but okay. So as long as we get a 70, it counts towards our.
So it's I graded a 90, 80, 70, 60.
Okay.
If you get 90 or above, you get an A. You get 80 to 90, you get a B. 70 to 80, you get a C. 60 to 70, you get a D, and below 60, you get an F. So that's the grading. So I if any of you know, I can't figure it out. I've sent a email to our distance ed coordinator who's supposed to know these things, and she didn't know. No one seems to know how to change that. So sorry about that.
No, that's just as long as I'm not, I'm fine.
Yeah, so look at your percent grade. Don't look at whether it says failing or passing, because that's meaningless. And I apologize, I can't figure it out. I've searched for help, and I'm a very high-tech person. I'm not one of these illiterate computer people, but for some reason this one's beyond me. I don't know how to change it.
Okay, thank you.
Yeah, and I've gone on Google. I've gone to so many places, and I can't get rid of that word. Sorry about that.
No worries.
Yeah. Other questions? Other questions? Okay, so I have a question for you. See if you can think about it. What haven't we done yet? So we've done a lot of, and you can set up hypothesis testing because that's what we've been doing the last month or so. What don't we know how to test for yet? Because we've done a lot of different hypothesis tests. What don't we know how to test? What kind of data? So for example, So we've talked about, deciding if a mean is big enough, deciding whether two proportions are comparable, deciding whether, qualitative data are independent for two questions. What don't we know how to do yet? We feel like we know everything, but we don't. There's still one thing left. 3 groups of data, but what kind of data? Because we know how to do some kind of 3 groups of data. Like if we want to, because you could do a test for independence on some things. Categorical, we know how to do actually. It's the other one.
Qualitative?
One more guess?
Qualitative?
No, not qualitative, but quantitative. Yeah, we don't know how to compare multiple groups of quantitative data. Okay, do you think that ever happens where you have more than two groups of types and you want to see if there's a difference in the means? Do you think that ever comes up?
Probably more often than not.
Yeah, it comes up, I don't know about more often than not, but often. It's a very common thing. So what we're doing in chapter 13 is we are going to be looking at survey questions or data collection at which there's multiple groups, and each group, each person or each thing in the group is going to produce a quantitative answer. And you want to find out, is there a difference between the means, among the groups, or are they all the same? Okay, very important. So let me tell you some examples where it's important. Let's say if we wanted to find out if there was a difference in income based on race. Okay, that's a biggie nowadays, right? Okay, it'd be nice if it didn't matter what your race was, that everything was fair and the average income was the same for all races. I mean, that would be a good society, don't you think? Okay, and you want to be able to figure out, is that true? Okay, or is there a difference in the means, or are some of the means different than other means when it comes to that? So that's an example where you care about comparing multiple different types, and hopefully you all know there are more than 2 races. Okay, or maybe states in the United States. How many states are there in the United States? You're all supposed to know that one. I know some of you aren't from America, but even then you might know. Yeah, there's 50 states, and you might want to find out, I don't know, how about the average weight? Is it the same in every state? Okay. Now some of you are shaking your head no. You've probably been to Alabama. but you could test that and find out, is the average weight the same in every state, or are there different, is it difference depending on which state you happen to be in? Does that make sense? And there's 50 states. Now, of course, I wouldn't give you a final exam question where you have to do data with 50 states. This is too messy. But in the real world, you can do that. And you have time to type it in a spreadsheet and you can do that. Okay. But I want you to understand how to do it. So you could test that. Okay. Or let me do another one. So let's do an example. And I'm going to make up numbers and stuff. So, don't quote me on this data. I'm just going to make up a bunch of data. So here's a question. Does it matter what season a person was born in? Oops, I think that's too big. That's better. when it comes to IQ. Okay, so you might think, you know, those winter babies, you know, they're the smart ones. What do you think? Do you think it makes any difference in terms of IQ on what season a person was born in? I don't know if you ever thought about something like that, but could that be tested? Could you look at statistics? So aren't the hypothesis tests we're doing with mean and proportions quantitative? What makes this quantitative? Okay, so that's a good question. What makes this quantitative test? So here's a good example, the IQ one. How is this different than what we've already done? And how many seasons are there? There's 4 of them. What we don't know how to do yet is do a comparison of more than 2. So if it was, you know, IQ for men and women, that we know how to do. What we don't know how to do is by season, because there's 4 of them. Okay, and you could say, well, let's just compare each season together. You do summer versus winter, summer versus fall, summer versus spring, winter versus, you know, fall, etc. What's the problem with that? What's the problem with just comparing every different combination? Anyone know the issue, the statistics, the statistical issue? Because we know how to do that. We know how to compare each of them, you know, one pair at a time. But what's the issue with that?
They wouldn't be compared equally?
You could compare them equally. That you could do. There's an issue, though. You may not come up with it. Usually, it's rare that I get people to come up, but it's really important. As soon as I say it, it makes a lot of sense. Takes too long is not a problem because you have computers. You can put the data in the computer can do it in a millisecond. So that's not a problem. Here's the problem. The problem is type 1 errors. So every single pair that you're going to do has a 5% chance of a type 1 error if you're going to use a 5% level of significance. Well, if you're looking at 4 seasons and you're doing pairs in 4 seasons, there's 6 of those. Just trust me on that. 4 choose 2, it's called. And then you're going to have like a 30% chance of a type 1 error if you use a level of significance of 5%, and that's a disaster. So what this ANOVA does is it takes that into account. And what I'm not going to do is the mathematics, and you're used to that. If anyone wants some torture, you can stay afterwards, and I can torture you with some really tough mathematics with involved calculus, but I'm not going to do that in class. But you can trust me. But what I will tell you is the test to use is called ANOVA. And ANOVA is an abbreviation for analysis of variance. So what I'm also going to tell you is don't even attempt to try to understand why we call analysis of variance. For you, it doesn't look like anything to do with variance, and it won't. But what I will tell you is the mathematics has variance in it that we're going to just totally ignore because we're going to just use a calculator. And again, if you want to learn, you know, more details, then you take a math major statistics class. Okay, and it's a little bit brutal, but let you know that it's called analysis of variance. There's variance involved, but you'll never see it. What we're testing for is means. Any questions on that? Okay, so let me state the hypotheses. Okay, and these hypotheses are interesting. So since we're also reviewing for the final today, if a hypothesis test comes from chapter 9, chapter 10, or chapter 12, how many words are there going to be in the hypotheses? So this is a review for the final. If it's coming from 9, 10, or 12, how many words? Not 4 words. Hasn't been that long. I know you had Thanksgiving break, but it's not that long. No. I don't see y'all jumping in. All right, maybe I'll tell you. Not 6, 0. It's all symbols, remember? Okay, so chapter 10 was like, chapter 9 was things like p equals 0.2 or mu equals 7. Okay, mu the symbol, not the word. Chapter 10 was like mu1 equals mu2. Chapter 12 was rho equals 0. Okay. If it's chapter 11, then it's all words. Okay, I can't ask you how many because it really depends on the question, but it's not 0. Chapter 11 is all words. Chapter 12 is a mix. So let me do chapter 12 with this example. And in this case, what we can say is H naught, and let's do it with symbols. H naught is, well, we're going to have 4 different means. So we're going to have the mean. Let me find mu, because mu is mean. Sub, let's go W for winter, equals mu sub S for spring. Actually, SP, because unfortunately spring and summer you start with the same letter. Sorry about that. I didn't do it. Equals, and then mu sub summer. So let's go SU for summer. Equals mu sub F. F for fall. Any questions on that? Because the null hypothesis is that the mean IQ is the same for every single season. Any questions on that? Okay, well, now we need H1. So H1 is a little interesting. H1 can get a little tough if, you got to think deeply. What is the opposite of them all being equal? Because remember, H1 means H naught didn't happen. Okay, so you got to be careful. The opposite is not that they're all not equal. Because say 2 of them might be equal, but maybe the third one is different than the second one. Does that make sense? So you can't just say they're all not equal, because that is not the opposite of H naught. So H1 the easiest way of doing it is using words. And that is at least 2 of the population means IQs scores differ by season. Okay, there's lots of ways of saying it. You could say there's at least 2 seasons that have different population mean IQ scores. At least 2 population mean IQ scores differ by season, but you have to get there. Okay, it could be that 3 of them are the same, but the 4th one's different. Do you see? Winter might be the weird one, where everybody in winter is smart, but then fall, spring, and summer are all the same. Maybe winter and spring are smart, and summer and fall are dumb. Low IQs. The point is that there's lots of different ways of them not all being the same. Oh, what does W, SP, SU, and F stand for? Well, the question is about season. There's 4 seasons: winter, spring, summer, and fall. There's even a beautiful song about it. But if I sang, you'd all close your Zoom because my voice is so bad. I'm a math person, not a singer. Okay. Any questions at all on the null hypothesis and the alternative hypothesis for ANOVA? Okay, just to let you know, we're using ANOVA, and the distribution is not normal. It's not T. It's not chi-squared. It's not uniform. Again, there's a review for the final, so I'm trying to mention all the different distributions. It's not binomial. If you don't know what any of those words mean, you need to study a lot before you take this final. Okay, it's a different distribution. So we will use the F distribution. Okay, and what I'm going to tell you is that the mathematics is very complex, which is good news for you because that means you don't have to understand any of it. See, if it's simple math, then I make you do it. If it's complex math, then it's too hard. But what I do want you to know is it's called the F distribution. So there's a different distribution. You know, there's going to be a curve, and there's going to be a p-value, and there's going to be an area to the right of that p-value. Yeah, I mean, to the right of the test statistic, and that'll be the p-value, just like we've done before with hypothesis tests. Any questions so far? Okay, so suppose we collected, actually, instead of collected, we tested the IQ scores for the sample. And they were as follows. So we tested a group of winters. I'll just write W for winter. And let's suppose that we had a 98 IQ, a 130 IQ, an 87 IQ, a 123 IQ. That's good enough. Okay. What I'm going to do, by the way, and I want to give you a big warning. This is a sample size of 4. Do you think that's really okay? Right? When you leave this class, yeah, do not do a sample size of 4 and think you're doing ANOVA properly. Don't even think about it. But, you know, so I'm not doing it to be mean or tricky or anything. I'm doing it because I don't want to waste your time. Otherwise, we'll be typing all day. If we have we're going to have to get over 30 for every sample size for all 4. So we're going to have, you know, over 124 in our, you know, IQ scores. And that would take all day long to type all those things in the program. So what I'm going to do is I'm just going to make some stuff up and make it small sample size. But in the real world, don't do sample sizes of size 4. It's a bad idea. Okay, you don't get any real statistics on it. Okay, so we have spring. And let's suppose we had an IQ score of 100. We had an IQ score of 110. We had an IQ score of 108. And we had an IQ score of another 108. And then we had a summer. And we had an IQ score of 94, of 147, and a 122, a 111, and a 99. And then we had a fall. And for fall, we had an IQ score of 102, 118, and 122, and 90. Okay. By the way, do you think you have to have the same number for each winter, spring, summer, and fall? Do you think the sample size have to be the same? The answer is no. Okay, you do not need to have the same sample size, but what you do need to have is a large enough sample size to have good data. So this isn't, but we're going to pretend it is. And if I give you on the final, you'll pretend it is also, because I don't want you to spend all day long on the final typing in numbers. Otherwise, you'll have no time. Just let you know that. Any questions at all so far? Okay, now we want to see, is there a difference between the means? Okay, certainly for the sample means, they're not going to be exactly the same. I can guarantee that. Even if I, even if I got lucky, there's no way I'm going to get that lucky now with a bunch of random numbers. But the question is, are they far enough away from me? Is there one season that's far enough away from another season that we're going to say, yeah, there is a difference? Any questions on that? All right, so this is kind of a very, very big day in that I can go to the calculator. And what calculator number do you think we're going to be using? Yeah, 25. Okay, you'll notice that there is no 26. We're done. Okay, we're at the end of the class. So this is the very last calculator number we're doing in the entire class, and it is 25. And we're going to enter the data values separated by commas, which means I can copy and paste because that's how I typed them. So our winter, our spring, then our summer, and our fall. And the way I've done it is there's a whole lot more if you happen to have them. If you needed 50, then this won't work, by the way, but I figured for a class, I would never give you more than 8 data sets because it's just too much typing. And hey, calculate. Notice that F is the test statistic. So that's what I told you, that it's an F statistic. And the test statistic is about 0.2, and the p-value is about 0.9. So let's write this down. And the p-value is p-val is equal to 0.9 is good enough. By the way, on your computerized assignments, don't do 1 decimal place. It'll zap you. Okay, usually 4 decimal places is what it wants. So I'm just doing this because it's good enough for learning. But make sure on your homework assignments, do lots of decimals. On the test, it's not that important. Okay. All right. What do you think? What's the conclusion? Hopefully we are far enough in the class now. You better know what the conclusion is when we have that p-value. So what's the conclusion? Yeah, there's insufficient evidence. This is a giant p-value. Okay, it's probably not even because of the sample size in this case when you have that big a p-value. So what we can say is there is insufficient evidence to make a conclusion. Whether or not. And then we can think that best is to do H naught, the population mean, IQ scores differ by season. Another way of saying it is that season, we don't have enough evidence to make a conclusion whether or not season is a factor in IQ score. So let's write that down. There is insufficient evidence to make a conclusion whether or not, season of birth is a factor in IQ score. Any questions? Any questions on this idea? I'm hoping that this feels like we're just doing another hypothesis test. Okay, but now we know how to do one with multiple, more than two different groups. Here we had 4 groups. Okay, so there's lots of different types of ANOVA problems that you could do. Often you could do it by season, you could do it by race, you could do it by, birthplace, you could do it by job, major. There's so many different times where you're going to want to look to see if there's a difference depending on something. So this was an example depending on birth season. So that's a really good question. Let's say we got a p-value as 0.001. Okay, so if you got a p-value of 0.001, then you would say there is statistically significant evidence to say that at least 2 of the population means are different. All right, hope I got some bad news or good news from you. It depends on what lies in your future. So you want to hear the news? So here it is. If you want to find out how to tell which pair differ, you need to take another statistics class because that'll be advanced statistics. We don't do that in elementary statistics, but there is a Tukey analysis, it's called, and there is another test to find out after you get a p-value that's small enough, then you do a further test that we don't have time to do in this class. Again, we haven't even done 1/10 of the different statistical tests that you could do, but we've done the biggest, most important ones. But there is a test to do what you were asking for, and that is which one differs. And that's called a Tukey analysis, which I'm not doing because, again, we only have so much time in this class. Okay. But I will let you know that there's a lot of tests out there. So if you decide to take more statistics in your life, you're going to see a whole lot more tests. And in fact, one time, because I've done a lot of consulting work in statistics for different agencies, one time I created my own test. I'm a mathematician, so I can do that. I was able to prove the test was efficient, and I created my own test, and I was able to show that there was statistically significant evidence based on a test that I created. Okay, and it wasn't like fantasy math; it was real. So I'll let you know there are a lot of tests, and you can always do more. Okay, and one thing that we haven't done, I want to mention this because again, it's good to know what you don't know, and that is we have not touched the median. Do you notice that? We define the median, but we haven't done anything statistically about the median. So there is a whole set of analyses about comparing medians, but we don't do any of it in this class. So I'll let you know there's a lot we don't do. And probably the biggest is the median. There's other biggies too, but I wanted to mention the median because that's one you understand. Any questions at all on this test, ANOVA? Okay, I want to give you a big word of caution. And that is, you may think you're doing ANOVA and you understand ANOVA, right? It was easy. I showed it to you. You watched me. You got it, right? Type it in, you put it in the calculator, it gives you the number, and you say there's statistically significant evidence. Okay, but now I mentioned that this particular one didn't work. Okay, I told you should never do what we just did. What was wrong with this one again? I mentioned it a few times already.
Small sample size.
Yeah, we have a small sample size. That's bad. So word of caution, and that is there are many requirements for ANOVA. Okay, and I'm going to list the requirements. One of them has to do with the sample size, but why do you need a big sample size? We've talked about this in our class already. The hint is, see if you can get the number, chapter 7.
Reduce the margin of error?
No, it comes from chapter 7. Margin of error is so that you have a smaller probability of a type, a type 2 or type 1 error. But that's actually, it's okay to have a big probability of it. You just got to understand if you could have it. But what did chapter 7 talk about? Again, this is a review for the final. That's why you got to know this stuff. What did we do in chapter 7? Yeah, something about the distribution. So the sampling distribution. For each of the samples. So we had 4 samples in our case. Must be, what word? It's a biggie. Kind of the most important word of the whole class, maybe? I don't know, normal. And we learned from the central limit theorem, if you have over 30, then you have a guarantee that you're going to be approximately normal for all of them, as long as all of them are over 30. If you have under 30, you better have some information. Okay. Now, do you think IQ scores are normal? Yeah, it turns out they are. Other than some outliers because of disabilities. But if you look at the IQ scores for non-disabled people, then it actually is approximately normally distributed. Standard deviation 10, mean 100. So actually that one you can do. Okay, so 2. And this is one that we haven't seen before, but it's an important one, and that is the standard deviations are all approximately the same, especially if the sample size is differ. Okay, now there's no reason to believe that's true, that the standard deviations are the same by season. I have no idea. Okay, so that's a biggie. Okay, and there's a test for it that's an advanced test that we're not doing in this class. So I want to let you know that you may think you know ANOVA when you're done, but then it's tough. Okay, the third one's a lot easier actually, and that is the sampling was done independently. So what that means is that if you look at the people that you did that were born in the spring and born in the winter, there's no relationship between them. So you didn't do like brother-sister pairs or something like that. And that's usually no big deal, but you have to know to do that. Okay, a fourth one is the sampling was all done in the same way. Okay, now this one's important, and this one actually, sometimes this one takes some work. And this is something that we haven't talked about that much because it has to do with reality. Sometimes we can't do reality. But let's suppose, instead of the season born, let's suppose you wanted to find out if IQ scores were the same by state in America. Okay, and you want to do it right, so you need to make sure that you survey more than 30 people in each state. Let's say you want to do 100 in each state just to make it good. Could you do that by yourself? And you had to go and test them, by the way. Because you can't just ask people what's their IQ. Most people don't even know their IQ. Okay, the answer is no. No one has that kind of time. You'd have to go to all 50 states, and each state you'd have to test 50 people in some random way. Okay, so what you'd end up doing is you would get a team of people. And maybe you get one person from every state, so you'd find 50 people. Some states you might be able to pair up because they're little tiny states, not like California. But you would get a team of people to do it, and you'd hire people. So what this says is that you make sure that you have a meeting before you do the survey collection to make sure that everyone is doing it in the same way. Okay. And again, that one's a hard one. Unless you actually done an involved study, as a student, you're not going to see that as a tough one to do, but actually it is. And as I mentioned, I was 11 years old and I was a worker at a market research company. That was before there were laws that, put people in jail for doing that to children. But it was, I don't know, some weird coincidence. It had nothing to do with me becoming a statistician, I don't think. But I got to do that. And we'd have our meetings because, again, we'd have a big group of people doing these surveys. And I would be this 11-year-old would be in this meeting with a bunch of adults mostly. And we'd make sure that we were all asking the question in the same way and handling everything in the same way. Does that make sense? Okay, another one, and this one we've seen all the time. What do you always have to have in any study? And the hint is we talked about in the first chapter, first day of class. Yeah, I had to unbiased sampling. So the sampling is unbiased. Okay, and that's very difficult. Okay, very easy to say in theory, very hard to do in practice. So you need to have the sampling unbiased. So ANOVA is harder than it sounds. Okay, it's very easy to do as a homework problem or a test problem, but it's not easy to do in reality. And there's been what's called meta studies, which is studies of studies. And they have found that more than half of all published papers that use ANOVA did it wrong. Because there's all these different things you have to do right, and it's very difficult. Any questions about ANOVA? Any questions? Okay, and that's all there is to it, by the way. Again, I think one example is probably enough. It's not like there's 7 different types of ANOVA problems or anything like that. They're not always going to be by seasons, or they could be by whatever, but they're going to look similar to what we just did. Any questions at all? Okay, well, the good news is we're done. Can you give a conclusion example for if it's proven? So let me tell you how, first thing is you just used a forbidden word. What's the forbidden word in this class? Now, significance is a great word. What's the forbidden? Yeah, proven is a forbidden word. Do not use that word on the final exam or you will lose points. So what you really want to say is, can you give a conclusion example if there is statistically significant evidence? Those are the words you need to know. It's not proven. So let's pretend, so I'll just do it here. Pretend we got a p-value of 0.002. Okay, so again, in the real world, no one's going to give you a level of significance, so you're going to have to see it and decide and talk about that, strong statistically significant evidence. Remember, strong means under 0.05. So then we say there is strong, but don't say strong if it was, say, 0.03. Statistically significant evidence to conclude. And the nice thing is, I can come up here and I can copy and paste H1. Because if it's in words, we've got it in words already. So it's copy and paste. I think I'm going to have to get rid of a capital letter at the beginning, and that's about it. So that at least should be lowercase at least. So at least 2 of the population mean IQ scores differ by season. We will use the F distribution. And that's it. Does that make total sense? So the test statistic. Maybe, let's see, I guess we have time. It's a bit complicated, but at least I can show you a picture. Since I did code it. This math wasn't as hard for me because I used someone else's math. Another time I actually did my own math, and it was brutal. And that is, I think that one. Let's see if I'm right. At least I think I coded one of these. Maybe I didn't. Maybe it's not in that one. Just a second. Might be facts about the F distribution. I forgot which section it's in. There we go. So here's some F distribution pictures. And I actually I coded my own. So I'm a programmer. So now we can actually see it. So the first thing is, it turns out there are 2 separate degrees of freedom for the F distribution. And I can only do so much. So I think I'm just going to tell you, trust me. You okay with that? Again, the math is brutal. So if you have different degrees of freedom, it slightly changes the distribution. Okay. Any questions on that? So that's a picture of it. So if the test statistic, let's say we did have these particular degrees of freedom, which are 13 for the numerator and 2 for the denominator, just trust me, they mean something. And let's say the p-value, let's say the test statistic was 2. So then you go over to 2 on the graph. Do you see 2? And the p-value is the area to the right of the test statistic. And that's how all test statistics work, is that the p-value is the area to the right, sometimes the area to the left, and it's on both sides if it's 2 tails. But it's always a picture like this. This is not a normal distribution. As you can see, the F distribution is skewed right. Okay, and that's what it is. Yeah, so it gives you, it gives you the p-value. Okay, so the p-value is the area to the right of that value on the graph. So the p-value is what you want, and the test statistic is the F number that shows you in the picture what the p-value is. So for example, if we got a test statistic of 7 with this combination of degrees of freedom, do you think you would reject or fail to reject? If the test statistic was 7. Yeah, you'd reject, because notice the area to the right of that number is really little. There's not much stuff there. On the other hand, if you got a test statistic of 1, then you'd fail to reject because there's a big fat area to the right. That make sense? So that's what the test statistic does. And I'll let you know, 20 years ago, we used to do it all with test statistics and tables. But now that there's computers and programmers like me, you don't have to do that anymore. And it's so much better. I promise you that the class was very different in the old days, where you had to do all the mathematics. And we didn't do very many topics because you were so busy doing math, and it had a much higher math requirement. So we dropped that because computers can now do it. Okay, I think what I want to do, and I never have to do this again, well, except tomorrow night, and that is the secret word. So this is the very last secret word of the entire class. And especially because you are here, the secret word is what I want to say to you all. And that is, it's actually 2 words. And I think it's okay whether it's capital or not. If I remember right. So the secret word is thank you, because you are here. And I know some of you, there may be a few of you that love mathematics, and this is your favorite thing ever to do in the world. But I know some of you that this is hard, and it's a struggle. So thank you for your patience and hanging through it. Hopefully you all work really hard and do well in the final so that I can pass y'all, because I want to pass everyone. And so that's the secret word. I'll make it bigger, maybe even red, since it's our final secret word of the quarter. All right, so guess what I'm going to spend the next half hour or so talking about? Yeah, the final. So now it's time to get into the final. So the first thing is the final exam. You have 2 hours. And I've sent out, hopefully you all read my announcements. Do you read my announcements? Okay, so I've sent out more than once the final exam schedule. So it's in the announcements. And all I do is copy and paste. So I definitely never make a typo because I copy and paste each time. It's always the same. So it's Sunday at 1. I got to do it by memory, but I'm pretty sure Sunday at 1, Tuesday at 8 a.m., and Wednesday at 6 p.m. And you must make one of those times. Okay. And when I say Tuesday and Wednesday, I don't mean tomorrow and the next day. Okay. So Sunday, this coming Sunday, and then Tuesday is 8 days from today. And then Wednesday is 9 days from today. And I want to let you know that it is a final exam. The word final means final. Please do not email me after the final exam saying, what can I do now for more points? Because once you've taken your final and hit submit, the class is over. Okay, then your class is over. The last thing to do is look at your grade. Okay, and that usually takes me a few days to just let you know it'll happen. I'm not a procrastinator, but it takes time. I also, for the final exam, I don't put comments because I don't think it's necessary, because it's not like you're going to be using my comments for the next test or something. So you're just going to get a score. And that's standard at universities. So I try to be somewhat standard. Is that, in fact, at universities, you never get to ever see your final again. I think you might be able to take a look at your final. I'm not even sure about that on campus. But the final exam is, will happen. I have written Sunday's final exam. I have written half of Tuesday's final exam. And my plan is I will have Wednesday's final exam written in the next couple days. So, I'm not one to wait till the last minute. But the final exam is written. And what I'm doing is, whether you take it Sunday, Tuesday, or Wednesday, the type of questions you're going to get are the same. The question itself is different. Okay, so the questions are all different, but what to expect are the same. So number 1 actually does not change. And in fact, it didn't change from the exams either. So you should all expect number 1, and that is, you better all get that one right, because otherwise I ignore all the rest of them and you just get a 0. And that is, you have to sign your name, basically saying you're not going to cheat. So you're not going to communicate with any adult, and adult means post-pubescent, and not use any devices or materials for this exam that have already been expressly allowed by your instructor. What material are you allowed to have? See if you remember. Yeah, so it's different than the regular exams. You get a full page, and a page is a standard page, this size, 8.5 by 11, a good old standard piece of paper. And you could write front and back, and that's a lot of writing, by the way. Okay, but you can't have a book. But basically, you could write a whole lot on a front and back of a page. And it's totally up to you what you write. You're going to show it to the camera, because it's Proctorio, and that's it. Okay, and whatever you put on it, that's great. Okay, as long as it helps you. If it doesn't help you, it's not great. But make sure you put all the things that help. So one thing that you definitely want to put on it, any guess? Maybe say 2 things, but it's just kind of the same 2 things. Yeah, you could have blank paper, and you got to show the camera the blank paper. That's fine. But what should you definitely put on your note paper? Your name? Yeah, that's not so important, actually. You gotta have that on your ID. not like you're mailing it to me or anything. Examples you can put. Okay, that's if you need it. Maybe I should tell you. Formulas, yeah, if you need them. But something more specific. Which test to use. That, yeah, but that's also a hard one to talk about. Maybe I'll tell you because no one's guessing. My suggestion is everything you put on your other note cards, write them out on the piece of paper. So everything you put on the first exam's note card and everything you put on the second exam's note card, put on the piece of paper, and there's still plenty of more space. You can get all that easily on one side of a paper and you still have a whole nother side. But I recommend just taking those note cards, hopefully you didn't throw them out, and just copy them onto a piece of paper. Any questions on that? Okay, so definitely want to do that. And then all the other things you said you should probably put on too, but definitely what you put on your other note cards. Okay, let me go through the rest of the exam. And so the rest are problems 2 through 10. And those are matching problems. And I think I've mentioned it before, what you're going to see, but now you're really going to see it. Okay, and I'm going to show you how to practice for those and where it is. Okay, then problems 10 through 19 are true false questions. I do want to mention that the points for the problems are not all the same. Okay, because if they were, most of the tests would be matching in true false, because then there's 20, 21, 22, 23, 24. And that's not how it works. I think I made it 2 points each for 2 through 10, 2 points each for 10 through 19. And I think it's like 10 or 15 points for the rest of them. So, keep that in mind. Okay. Don't just think that if you can do 2 through 19, you're gonna ace the test. Because again, they're not as many points per problem as the rest of them. But they also are real quick. You read it and you write down what it is. You click. It's all on computer. Okay, they're self-graded, there's no explanation, you just click which one it is. And same thing with true or false, you click true or false. Any questions on understanding at least 1 through 19? Okay, so problem 20, I actually did a copy and paste from the problem itself, except that I didn't copy the whole problem. There's a whole paragraph before the word state. But you're going to be given some information, and then you're going to have to state the null alternative hypotheses. You're going to find the test statistic. I think actually this is number 1 is state the null alternative hypothesis. When I copy and paste never works with numbering. If you ever tried to do it, just trust me on that. You need to find the test statistic and the p-value. You need to state your conclusion in the context of the study. I want to ask you, see if you remember, because you had to do this on exam 2 also. What is the first word you should have for this part 2, which will be part 3 on the regular exam? Yeah, there. Okay, there. Okay, what's the second word? Is. Good. Okay, there, you get a note card. I mean, a note sheet. There's no reason not to get those first 2 words right. It gets you started. You don't know how many people got those first 2 words wrong on the last exam. And there's no reason for that because you get a note card. Okay, put that in a note card. Okay, it's problem 20. I think it will be part 3 though, because again, this numbering got weird. Okay. Then, number 3, use a complete sentence to interpret the p-value. Okay. Now, p-value is all about that if the null hypothesis is true and you did another study with that sample size, then the p-value is a probability that you're going to get something as extreme. Do not write those words word for word. Okay. You have to write it in the context of the study. Don't just define what a p-value is. Okay. And I'm not going to tell you what the study's about. And in fact, that's going to change depending on which day you take it. Okay, so all of you are going to have, this problem number 20 being a hypothesis test, but the paragraph ahead is going to be different for each of you. Okay, and then 4, why is it or why is it not appropriate to use the normal distribution for the hypothesis test? Okay, and you should be thinking about proportions versus means, real important. Different answers depending on it. Okay, 21. For each part, write down the sampling distribution. Answer the question, then determine if you needed to assume the distribution. Oh, wait, this got changed. I'm going to erase this because this is from the old test. Distribution ... is normal. Okay, I want to ask you something. Read number 21. How many things does it ask you to do? Three. Okay. Now, I'm not sure what I can do. It didn't work last time. Maybe it'll work this time. But promise me you're going to do 3 things per part of 21. And there's multiple parts, by the way. Do you remember seeing this on your last exam? It's the same question, right? It'll be, with different numbers in a different scenario, but it's the same question. Get it right this time. Okay, some of you got it right last time too, but a lot of you didn't. And a lot of you just ignored the parts. And all you did was part 2. Okay, and make sure you do part 1, part 2, and part 3. Part 1, what symbol must be in part 1? See if you remember. It's been a while since we did this. See how your memories are. What symbol must be in part 1? That's writing down the sampling distribution. It's not a letter, it's not a number, but it's a symbol. But you have it on your keyboard. All keyboards have it.
Is it that one that starts with a T, Tyndall or Tin?
You got the idea. That's all that matters. You don't have to have the name of it. So that one. And it's called tilde, by the way. You don't need to know the word tilde, but you could have just put it in the chat box too. That's easier, I think. Because for some reason, most people don't know the word tilde. But that'll help you. So don't forget, well, I should probably put that under 21. Make sure you got that symbol in. Now you don't need to know the word tilde, but you need to know how to type it. So it's either going to be X tilde or X bar tilde or sigma tilde or P hat tilde. And then it's going to have an N after that, by the way, because this is a central limit theorem problem. Okay, or it could be normal distribution problem. Any questions on that? Okay, and I want to remind you in the central limit theorem, if you're looking at a total or a sum, that's very different than if you're looking at an average, which is very different than if you're looking at an individual. So don't ignore those. You will lose a lot of points if you ignore those words. Got it? Okay. Problem 22. Doesn't like my grammar, but I like my grammar. Is a chapter 3 and, not or, and 4 question. So it has multiple parts, and I ask you to do things from chapter 3 and from chapter 4. Okay. Do you remember what the chapter 3 and chapter 3 and 4 did? Some of you hated chapter 3 so much it might not even be in your brain anymore because you want to blank it out, but don't. Chapter 6 was area of a rectangle. Sorry, chapter 5. I meant not 6. Chapter 5 is area of a rectangle. There's binomial, that's a piece of it. And what else was there? Probability, good. What else was there? Starts with an E, that's a hint. 2 words. Yeah, expected value. Okay, I'm not going to tell you what it is because I want you to study it all. Okay, but it's more than one chapter. So it asks you to do multiple things. There's these have parts. Okay, 23. I'm just going to tell you it's a confidence interval question. Okay, notice there's a big difference between what's the conclusion, or what is interpret the interval versus interpret the level. Don't get those confused. Interpreting the level, what are the first words? Yeah, if many. Interpreting the interval, what's the first words? Or first word? Remember? With. To be like with 95% confidence. Remember that? We did it. I know it's been a while, but we did it. Okay. So you should know how to do that. You should also know how to do sample size calculations and understand how to find a sample size needed for a margin of error, etc. Okay, that's all confidence interval stuff. Okay, 24. 24 is a confidence interval question. A hypothesis test question is what I meant. So you're going to have to state a null and alternative hypothesis. You're going to write down the test statistic and p-value. And sorry, I did a copy and paste. I think it was a 1, 2, and 3. Not a nothing 1 and 2. Apologize for that. And then state your conclusion using a complete sentence. By the way, if I write state your conclusion, first word. There. And don't go into if. There's no ifs on that question. There's no there's no if another study or anything like that. That's not a conclusion. Okay, question 25 is a chapter 2 through 5 question. Okay, so I'm keeping that one open. So, and it's more than one chapter, multiple chapters in it. So you have to know how to do those. Okay, question 26 is a chapter 12 question. What was chapter 12 all about? No, that's 13 was that. Not proportions. That's what Thanksgiving does. It makes you forget everything. You have regression analysis. There you go. Okay, so that was regression analysis. So the things I'm going to ask you to do is find the equation of the regression line. You're going to, so let me finish my sentence and I'll take your question. You have to find the equation of the regression line. You're going to have to know how to do a hypothesis test for a correlation. You're going to have to know how to interpret the slope, how to interpret the y-intercept or say that there's no good interpretation. You should be able to interpret r squared. There's a lot of pieces to that question. Okay, we had a whole chapter just on that you haven't been tested on yet, so that's important. Okay, so Joaquin, you had a question about regression? This is a good time. You could say it or type it. While you're thinking, I might as well mention, don't do anything with cause and effect, pretty much for anything we're doing in this class. The only time you can ever do cause and effect is when you're doing a randomized control study, which is very rare. And that won't happen with regression analysis. You almost can't do it with regression analysis. Okay, so LibreText calculated for regression, it's locked on two-tail. Okay, so the first thing is on the final exam, you will not be asked a left tail or right tail. But if you want to do a left tail, right tail, let's suppose The two-tailed test gave P was equal to, how about 0.03? So then, and let's suppose that it was and you want, actually I better write down Gabe, let's say T is equal to, I don't know, 2.7. And P is 0.03, and you want the right-tailed p-value. Okay, so you want to do a right-tailed test instead. So what do you have to do? Well, the idea is the two-tailed test gives the area of both tails. So for just one tail, if both tails are 0.03, one tail is half of that, right? Because the tails are symmetric. So one tail would be 0.03 over 2, which happens to be 0.015. Okay, now if it's a right-tailed test and the T is 0.27, that means T is positive and you actually are on the right, then it really is a p-value of 0.015. Okay, if you wanted a left-tailed test, you just take 1 minus that. If T is positive, then you're going to have something that's bigger than 0.5. Does that make sense, Joaquin? Yeah, you won't be asked that on the final. Just on, there were some home problems with it, but no final exam question. Okay, well, question number 27. I'm not going to tell you which, but it's a chapter 11 or chapter 13 question. And you have to know how to do those. So 13 is what we did today. 11 we did I don't know, 2 or 3 weeks ago. 3 weeks ago, I think. So that is the final exam. I want to mention something. I want to show you something. That is, let's see, that one. If you go to comprehensive final, there's review applets. And if you click review applets, these two, practice classifying statistics problems and practice true false, that'll get you the first out of 19 questions. Actually, not question number 1. Y'all better not need a lot of preparation for question number 1, because that's writing down your name. Okay. So this practice classifying, if you're going to do for the final exam, select all, because you need to practice everything and hit submit. And then you should practice. All right. By the way, where is this? So again, what you do is you go to the review applet. So let me show. So from the home page, you go to the comprehensive final, you see review applets. You click on that. It sends you here. It gives you a warning about not being secure. Don't worry, I'm not going to give you a virus, I promise, I wrote this. And you click review applets. And then the first one here, practice classifying, is it. Okay. And there it is. Okay, so let me just read one. A realty firm is interested in whether there are certain days of the month that are more likely than others for selling a house. Data is taken over the last several years. Which one is this? What's the answer to this one? Okay, so let's try ANOVA, see what happens. So one-way ANOVA. Okay, see that little frown? That's a bad sign. You should always read what it says. There are not more than 2 variables here, right? So ANOVA has lots of choices, lots of groups. Okay, we don't have lots of groups here. So what do you think? So try again. It'll guide you to the right one if you keep trying, but you always have to read the guide. Any thoughts? You're not going to lose points in the webinar. And the chat box other people can't see, so they don't know it's you. Confidence interval for proportions. Okay, so confidence interval for difference between 2 proportions. Notice that we want to make a decision, not an estimate. Do you see that? So we want a decision, not an estimate. So a decision is a hypothesis test. So hypothesis test for the difference in 2 means. Okay. Now there's 2 of those. Is it independent or dependent? Dependent. Let's try it. Nope. This is a chi-squared test. Try again. So now at least we know it's one of the chi-squareds. So it's not going to be a population proportion. It's chi-squared. You got 3 choices here. How much in 80? Let's try it. Okay, only 1 sample. We're comparing it with a known distribution. Goodness of fit. Let's try again. Nice work. Okay, we got there. For some reason, my little smiley didn't didn't make it. I don't know what happened. Something weird happened with it. Just a note, by the way, how many people do you think have used this app? What's your guess? Yeah, tons. I'm looking for numbers here. Yeah, over 5 million. Okay, over 5 million students have used this. This is like the national app for statistics now for this kind of stuff. So I'm pretty proud of it. When it went down for a day, like a couple months ago, it was awful. Yeah, I made this. It went down for a day. I got tons of emails saying, what happened? So there, and especially high school, AP statistics uses this a lot. This is like what everyone uses. Okay, so, and there's hundreds of these. How many should you do until you're ready to take the test? At least that part of the test. What do you think? Well, everyone, there's hundreds and hundreds of them. So everyone, you're probably not going to be able to do that many. I recommend getting 5 in a row correct. That means you've got it. If you can get 5 in a row correct, you've figured this out. If you're getting every other one correct, 50% is an F. Don't even think about it. You need to keep going. So I recommend 5 in a row correct, and then you probably got it. Statistically, again, it's not that big a sample size, but it's pretty unlikely to not know what you're doing and get 5 in a row correct. So when you say matching, well, I don't give you a matching question. This is what I give you. It's going to look like this, except it won't have a green background. It's going to have a paragraph, and then you're going to have a lot of choices, and you have to click the choice that's true, that's correct. So I can get, there's no reason to do an example of matching. Yeah, so this is what's on the final. So you have to match what is it? Yeah, so it's a multiple choice, but it's many multiples, many choices, and you have to pick the right one. It's this, basically. The true falses, well, that looks like true falses, and there's, again, practice for that too. So again, you can select all, and you can try some true falses. And I'll let you work those out. Okay, and those are good to try. And I'll let you see how you do. Again, I'm not going to spend all day because this is what you're supposed to do. Any questions on studying, at least for that part of the test? Okay, if you can't do that first part, You're not gonna be able to do the last part either. I mean, you have to know what kind of hypothesis test to do, for example, or you're gonna be messed up. So you gotta make sure, where to go. If you can't categorize, then you're in trouble. Any questions at all on that part of the exam? Okay, how should you practice for the rest of the exam? So let me go back to all of this stuff. What are some good ways of practicing? Okay, homework, but you have to do the homework correctly. Okay, don't do the homework like you did the homework. What I recommend, and maybe I'll pop in the homework just so you can see what it looks like. I'll just do it this way. I think it's the fastest. I'll just randomly grab one. So here's homework, for example. And you'll be doing it in review mode, of course. You don't have teacher preview, but it's just a little faster for me. So on the ones that aren't true, false, I'll pop one in like that. So what I recommend you doing is not reading the whole problem. I recommend you only reading like part A and then try and do the whole chi-squared after that. Okay. And then, like I said, don't read these. Do them without reading them, because you're going to have to be able to do it without reading all. I'm not going to take you through each piece. Okay, you're going to have to know all the pieces to do. Does that make sense? Previous exam is also something you should practice. The other is I recommend you going to I'll just grab a week. I don't know, how about week? I think 7, you had it. I recommend you go into the discussion and reviewing my model post. So you're gonna have to do a lot of typing and understanding the wording in these, like this hypothesis test for a difference between two means. And that should help some. Yeah, and the webinars is another place you can review. They're all on YouTube. So you can look at that. And remember that you can find that if you go to the syllabus. Then you will find full-length YouTube. Let's see. The archive lectures right there. And there's a lot of places you can find stuff. And this gives you all of the, this gives you all the webinars. Doesn't have this today's yet because we're not done yet. Okay, so that's another resource. And there's lots of other resources. By the way, this was last quarter, and there's lots of examples in this Eve class that I did. And there's a lot more lectures. So there's an overwhelmingly amount of review materials you can go and look at. But if you're not typing as you're reviewing, you're not doing it right. Okay, so what I recommend is either you have two computers, so you got two screens or two screens. One screen you do your typing, and the other screen you do your watching, and you want to type before it's said so you can practice doing a test instead of just watching me do stuff. Or if you only have one screen, then you put half, you do two pieces in your screen so that you can type on one piece and read on the other piece. That's what I recommend doing, because you want to practice typing, because that's how you can take the test. Okay. We're kind of getting close to the time at 7:25. I expected this one go to the end, which is, I try to always be done by 7:30. Are there any questions about what to do for getting ready for this final? Yeah, so my office hours are still the same. So tomorrow at 3:10 to 4:10. Wednesday from 10:15 to 11:15. Thursday 3:10 to 4:10. Friday 11:15 to 12:15. And if you take the test Sunday, it's over. If you take the test Tuesday, then I have one on Monday at 10:15. And then if you take the test on Wednesday, I have one on Tuesday at 3:10. So same as always. But I'll also be checking, I'll be checking the discussion boards a lot. Okay, I'm pretty quick with that. And by the way, there is no excuse to not get a 10 on this week's discussion assignment. I know a few of you have already done it because this is just a nice one. Don't have to do any statistics. Is there a calculator for chapter 2? Yes. So let's go back to the calculator. This guy. So back to the calculator menu. And that's the one variable statistics calculator. Is the main one. And you type in your stats. You decide whether you want a population mean or population standard deviation, and then calculate. You can also do frequency table. That's also chapter 2. You could also do z-score. So there's a lot of chapter 2s. Z-score is chapter 2 also. And that's the z-score 1 calculator. So hopefully that helps. Yeah, so I really tried to make a calculator for everything. The only thing I didn't make was just a general calculator, like arithmetic, because that's in Proctorio. I'm thinking about doing it because I get complaints that people don't like the Proctorio one. So I might eventually embed a basic calculator in each of them. Any other questions? Yeah, I don't. It's weird. I don't get to see the Proctorio calculator. I don't have rights to it. I can't look at it, so I don't even know what it looks like. So I've heard some, complaints about it, but I don't know if I have time to put a different one in. That takes a lot of work. So that's a good question. When are the grades going to be up? So that's a few things. First is that I'm not a procrastinator. I will get him to the college definitely by Friday, probably by Thursday. Because remember, Wednesday evening from 6 to 8 is the last chance to take the final. And I'm not a night owl. So you don't want me to grade your final after 8 p.m. because I'll make lots of mistakes. I don't do that. So Thursday, a week from this Thursday, by the way, not this Thursday because you won't have taken the final yet. So Thursday is when I'll do it. The problem is that it gets sent to the college, and the college usually waits until the following week to post them into your transcripts. So I don't have any ability to do anything about that. I send mine way early, and then they take forever. Does it have that squiggly we need to use? Well, that's not a calculator thing. That's just shift. That's shift, and then it's a button next to number 1 on your keyboard. Yeah, so I'll put it in the message. Shift next to 1, and there it is. You can call it squiggly, it's fine. It's called tilde. But that's just that's just on your keyboard. I think I'm gonna unshare my desktop at 7:30, and I try to promise not to force you to stay longer than that, but you can if you want. So let me stop the share. And I'm gonna let you know that this is, for those of you who are watching this, this is your last webinar. I will be giving one tomorrow, but it's just a repeat of this one. And Braulio will be there for help. I don't know when your last day of tutoring is. Maybe you can mention it.
So I actually haven't figured that one out. Next week is finals.
Yeah, so their choices on final are Sunday, Tuesday, and Wednesday. I give them 3 choices.
Oh, they'll be normal all the way to the end.
Okay. After Wednesday at 6 o'clock, there's no reason for you to have any any tutoring.
Right, so I'll be working right up until Wednesday, so
Okay, great.
same hours.
Great. I'm going to stop the recording.